Hi, this is Mr. Rubenstein, and this is the second part of a tutorial about how you can use two theorems from geometry to get a two-decimal approximation for pi using a method invented by Archimedes in around 250 BC. So his general idea was to create a circle with radius a half. That circle's circumference would be exactly pi. Well, by circumscribing a regular hexagon around the circle and finding the exact perimeter of that hexagon, we'll get an approximation for pi that will be a little bit bigger than pi. To get the perimeter of a hexagon, the thing to notice is that a hexagon can be split up into 6 equilateral triangles. So here's an equilateral triangle that you can see on the left, and if I take away the circle and the rest of the polygon, I want to show you how we could find the length of AC, which will be half of the side of the equilateral triangle, and from that we can multiply that by 12 and get the perimeter of the hexagon. All we really know is that AO is 1/2. Now to get the length of AC, I'm going to call that length x, and this would also be x in a equilateral triangle. If you draw the median, it will also make right angles. If you have right angles, it's the median. This would be 2x, because the entire side is 2x. And what we know is that the length of AO is 1/2. Since that was given to us. Now, this triangle happens to be what's called a 30, 60, 90 triangle. And there's a relationship in a 30, 60, 90 triangle that the side across from the 30 is the side across from the 60 divided by the square root of 3, which is 1/2 root 3. And if you do that on a calculator, you would get x equals, rounded as 0.288675. If you multiply that by 12, you will get, multiplied by 12, you get 3.464. Which is pretty close, but bigger than pi. Now, if you don't like the 30, 60, 90 rules, you could also use the Pythagorean theorem to solve for x also. See, this is a right triangle, AOC is, so we can say x squared plus 2x squared equals 1/2 squared. And if you run that through, you will end up with the same answer for x. You'll get x equals this, which is 2.88675, and again, we get our first approximation for pi to be 3.464. And this is a pretty good approximation, but I'm going to show you how Archimedes is then going to do something very clever to get a much better approximation. The major insight here is that if there were more sides, we would have a better approximation for pi. So here there are 6 sides. And what Archimedes figured out how to do is how to take the approximation for 6 sides and figure out how much it would be, not for 7 or 8, but he doubles it. He ends up all the way at 12 sides. 12 sides, the perimeter of this 12-sided regular figure will be closer to pi than the one for the 6-sided figure. So the question is, how do we get the length of AD? AD is going to be half of one side of the 12 gon. Well, take a look over here. If I go back to the hexagon. Here was AOC, and we worked out the size of AC to be about 2.28. If we bisect the angle AOC, that line OD will be, or that point D will give us AD, which is going to be, if you take a look, when I go to the 12-gon, it is the exact size of the 12-gon. So we're going to get an opportunity to use the angle bisector on this picture. Again, we know the length of AC. We just worked it out to be about 0.2886. Now we know the length of OC already. We know the length of AO. And with that and the angle bisector theorem, we're going to be able to work out the size of AD. And I'm going to show you how to work that out. And once we know the size of AD, we can multiply it by 24, and that will give us our next approximation for pi. Now we established before that CA was 0.2886 approximately. Now AO was 0.5. And OC was double the OC was double AC, so that's about 0.5772. I'll just round here. Now we have an opportunity here. If we know all three sides of a triangle, we could use the angle bisector theorem. Our goal is to figure out what AD is. So if I call that x, then this one would be 0.2886 minus x. And now I can use the angle bisector theorem. Angle bisector theorem says that I can set up a proportion which says 0.5772 over 0.5 will equal CD, which is 0.2886 minus x over x. When you cross multiply, you get 0.5772x equals, when you cross multiply here, you get 0.2886 times a half is 0.1443 minus 0.5x. When you add 0.5x to both sides, you get 1.0772x equals 0.1443. And then finally, when you divide both sides by 1.0772, divide this side by 1.0772, you get an answer which I'll put up here of x equals 0.1339 approximately. And that's the length of AD. And if we multiply that by 24, we get our next approximation for pi, which is going to be 3.21539. And that's an even better approximation for pi. Well, for Archimedes to get an even better approximation, he's going to go the next step, which is going to be to increase this from a 12-gon to a 24-gon. Now for the 24-gon, this was the AD that we just figured out. That was the size of the 12-gon. If I come over here and bisect AOD, angle AOD, I get this. And AE will be the side of a of the 24-gon. I'll show you that in the next part of this tutorial.